Find the surface area of the shape created by revolving y equals x cubed for 0 less than or equal to x less than or equal to 1 about the x-axis. Okay? Draw a picture. Draw a picture. Here's the little axes, and y equals x cubed is something kind of like this. It starts actually at 0. I know it's a little bit up. Pretend it actually touches the x equals 0. And then it's revolving about the x-axis. Not symmetrical, not the same. Okay, so we get kind of this horn type shape here, and it's from 0 to 1. And so for the surface area then, we're going to make a whole bunch of flared tubes, kind of like this, and we'll go from 0 to 1 of pi r dl, 2 pi r, because 2 pi r is the circumference of a circle, and then we're going to multiply that by the dl. Your first thought might be like, well, this radius is bigger than this radius because it flares out. That's true, but it's not going to have a significant impact. I know that's not very convincing, but you're going to have to kind of trust me on this one. But the angle will have an effect on the surface area. So that's why we do dl here instead of dx or dy. Okay, so now we know that r is going to be y, because this is the y value right here, which is going to be x cubed. So we got that. Now we need dl, and since we found radius in terms of x, we're going to want to find the arc length in terms of x as well. So dx squared, dy squared, square rooted. We factor out the delta x, and then simplify, rearrange things a little bit, and we get the arc length formula. So we'd get 1 plus dy dx squared dx. So the delta x became a dx, moved over to the other side, and then the dy dx, when I factored out the delta x, we got delta y delta x, and then we converted that into infinitesimally small and a derivative. So we need to find dy dx. We know that y equals x cubed. Therefore, dy dx would probably be 3x squared. 3x squared. Dy dx squared would then be 9x to the 4th. So we have the formula to tangle with of blue. I just used blue. Purple. So we'll go from 0 to 1, and I'll put the 2 pi out here because it's a constant. You can just kind of factor it out. Of r, which is x cubed, times 1 plus 9x to the 4th square rooted dx. Okay, so now this just becomes an integration problem, a solving the integral type issue. So when you solve an integral, first thing you want to look for is power, like a power rule. So, if it's just x to the 4th, then it goes to whatever. That doesn't work here. Next thing you want to look for is u substitution. Look for one thing that's a derivative of another thing. So what we see here is this 1 plus 9x to the 4th. When you take the derivative, we're going to get x cubed, more or less. And so that's what we're going to go for. That's what we're going to use here. We're going to do u equals 1 plus 9x to the 4th. So when we take the derivative here, we're going to have du equals 36. 36? 36x cubed. Is that right? Maybe that's right. We'll see. Okay. And so we have du equals 36x cubed. Maybe. Yeah, okay, let's go with this. Dx. And so then du is du over 36 is x cubed dx. This gets rewritten. I'm going to leave the limits of integration off because I don't want to do the whole transform limits of integration thing. So we have 2 pi. We have 1 plus 9x to the 4th square rooted. No, whoa, shouldn't have any x's in there. We got rid of the x's. That's the whole idea of this. Okay, we have u to the 1/2 du over 36. There we go. So we have pi over 18 u. Now we can do this because it's a power rule. So 1/2 plus 1 is 3/2 multiplied by 2/3. Seems reasonable. Seems reasonable. And so we're left then with 2 pi over 48 u to the 3/2, which equals 3 times 8. Is that 48? I think it's more like 3 times 8 is 24. I think it's more like 54. 3, 18, 4, 2, 3, 54. Yep. 2 over 54, which becomes 1 over 27 u to the 3/2. Simplifying again, we have 1 over 27. 1 plus 9x to the 4th. 1 plus 9x to the 4th. And this will be evaluated from 0 to 1. I think it's 0 to 1. 0 to 1. Okay. This has been a much longer trip than I initially expected. I'm going to clean up the board a little bit just because it's kind of not gone off the rails, but it's got a much more adventurous journey than I initially intended. Whoop, straighten this guy out. So now, plug in the numbers. We get 1 over 27 times 10. Ooh, isn't there a 3/2 in there? Did I just forget some sort of 3/2? I think I forgot 3/2. Oh, there we go. So we got a, yes, supposed to be a 3/2 right there. Okay, I don't think I'll erase it this time, just because my confidence has been shaken. So 1 plus 9x to the 4th, where x is 1, then we will have 10. 10? 10. Yep, 9 plus 1 is 10 to the 3/2. And then we will minus from this, when we plug in 0, 1 to the 3/2. So we'll have 1 over 27 times 10 to the 3/2 minus 1 to the 3/2, which will be 1 over 27. I'll call this 10 square root of 10 minus 1, because 1 to any power will just stay as 1. You don't have to fiddle with that much. Okay, and so this is our answer. Scooch over here. See if it's anywhere. Ooh, I think I forgot a pi somewhere. Did I drop a pi? Should never forget about the pi. Whoop, whoop. Pi. Yep, right here. Pi. There we go. That is not the correct way of doing pies. Okay. So, we have right there. That's the answer. So we have, so to backtrack to kind of see where we went, where we came from, we're given an equation. We're told to find the surface area of it. So we did 2 pi r, which is circumference, and then multiplied by dl, which is the length, Pythagorean theorem style. Delta x squared, delta y squared, square rooted. We use that to solve for delta L, plug that into our formula, did some calculus, and we resulted in a u substitution integral problem, which was, it wasn't too bad. Would have been easier if I hadn't made so many mistakes. And eventually we got an answer that was to something to the 3/2, which we then simplified to 10 squared root of 10 minus 1 times pi over 27. That is the answer. So thank you for sticking along for this one. I will see you on the next problem. Take care.